Hey guys, so today we're just going to be going over the second half of our gas laws lesson. We're going to be doing our molar volume as well as our ideal gas law. So let's get into it. So the molar volume of gases is essentially just this idea that if you have 1 mole of a gas at a specific temperature and pressure, it's going to take up a specific amount of volume. The molar volume of a gas at SATP is 24.8 liters per mole, and the molar volume of a gas at STP is 22.4 liters per mole. Now you don't have to remember those values, the 24.8 and the 22.4. Those will be on your formula sheet, but you do want to know what STP and SATP are. So STP is 1 atmosphere, 25 degrees Celsius. SATP is 1 atmosphere, 25 degrees Celsius. STP is 1 atmosphere, 0 degrees Celsius. And other than that, the formula is just V equals NVM, where V is the volume, must be in liters. So if it's in milliliters, make sure you convert it. N is our moles, which you might have to calculate. And then Vm is the molar volume, which is either going to be the 24.8 or the 22.4, depending on whether this is at SATP or STP. So let's work through some of these questions together. Okay, so for this first question, it says, what is the volume of 0.6 moles of carbon dioxide at SATP? So we're looking for our volume, our moles is 0.6, and our Vm, if you just look on your formula sheet or go back to the previous slide, you'll see that at SATP, our molar volume is 24.8. So we are just going to plug in 24.8 where the Vm is. And then I just multiply those two together. So 0.6 times 24.8 is 14.88, and my units would be liters. So pause here and see if you can solve the second one on your own. Okay, for the second question, I plugged in the volume that I was given. We don't know our moles, that's what we're looking for. And at STP, molar volume is 22.4. And then in order to isolate my N, I just divide by the 22.4, which gives me 0.536 moles as my answer. Okay, next up we have the very last law, which is the ideal gas law. It describes the relationship between all of these different things that we've been talking about: pressure, volume, temperature, which are all in the combined gas law, but also moles, the amount of the gas. Again, just a reminder, ideal gases are gases that obey all of the assumptions of the KMT, the kinetic molecular theory. But real gases are not ideal gases. They, don't always follow those rules. However, when we're at STP or SATP, when we're at kind of normal conditions, those real gases are close enough to ideal that we can pretend that they are ideal so that we can use this ideal gas law and our other different gas laws for calculations. It's only at really high pressure or low temperatures that the real gases start to behave super differently from ideal gases, and then these gas laws don't work anymore. So we can use this ideal gas law to kind of estimate how real gases will behave in different conditions, as long as those conditions don't include really low temperatures or really high pressures. So this is the formula for the ideal gas law. It's PV equals nRT. The P is pressure, which we measure in either atmospheres or kilopascals. The V is volume, which has to be in liters. N is, of course, moles. R is just a constant. So you'll just be given that. It's going to be on your formula sheet. And then T is temperature, and it must be in Kelvin. And then over on the side here, we have the two different possible R values. Again, these are going to be on your formula sheet. For both of them, again, we're going to be using liters for volume. But if we're using atmospheres for pressure, then we use this R value, the 0.081. And if we're using kilopascals for our pressure, then we have to use this R value, the 8.3145. So let's try a couple practice questions. Okay, we're actually going to work through question number 2 together because it's the trickier one. And then I'll let you guys try number 1, which is definitely an easier question. So I'll start with my formula, PV equals nRT. And I'm going to plug in my pressure, which is 130 kilopascals, my volume, which is 11 liters, and I don't know my moles right now. My R value, because I'm using kilopascals, it's going to be the 8.314, 8.3145. And I also don't know my temperature at the moment. So you might be wondering, how do I solve this when I have 2 variables? Because you're right, we cannot solve something with 2 variables. However, I do have my 135 grams. Now, grams cannot be plugged in directly to this formula, but I can convert between grams, which is mass, and moles using my moles equals mass over molar mass formula, which you would have learned about in grade 10 chemistry. So if I just plug in my mass, which is 135, and for my molar mass, I've got to look on my periodic table at the atomic mass of nitrogen. So if we look on the periodic table here, nitrogen has an atomic mass of 14 because, I'm just going to go off to the side here to solve for molar mass. Because nitrogen is diatomic, it's one of our Hofbrinkel molecules, I have to take this mass of 14, which is for 1 nitrogen, and times it by 2, since there's 2 nitrogen. And that'll give me a molar mass of 28, which I can then plug into my moles equals mass over molar mass formula. So step 1 had to be to find my molar mass of nitrogen. Step 2 is going to be to divide my mass, which was given to me in the question, by that molar mass that I just calculated to get 4.82 moles. And then now that I have those moles, I can go back to my PV equals nRT and plug in my moles. Now I'm going to be able to start solving for temperature. So 130 times 11 is 1430. 4.82 times 8.3145 is about 40.08. And then to isolate my temperature, I just divide by 40.08 on both sides. 1430 divided by 40.08. And I get 35.68 as my temperature, which of course is going to be in Kelvin. Temperature is always Kelvin, not degrees Celsius. Okay, so this is a kind of trickier ideal gas law problem because we weren't given moles. So we had to calculate moles first, which meant you had to calculate molar mass even before that. But you will definitely see problems like this. Or a problem where, you know, you're given everything except for moles, but it's asking you for mass instead. So you are going to have to use these 2 kind of processes, the calculating molar mass and our moles equals mass over molar mass, a lot of the time when you're using the ideal gas law formula. However, you're not going to do that for question number 1. That one's much more straightforward. Please try that one on your own. Okay, this question is much more straightforward. I plug in my pressure. I don't know my volume. I plug in my, I plug in my moles, which I was given in the question. My R value is the 8.31 because I am using kilopascals for my pressure. And then I do have to plug in my temperature, but don't forget you have to convert it to Kelvin first by adding 273.15. And then I just divide by 125 to isolate the V, and I get 25.6 liters. Okay, so that is all for today's lesson. Please let me know if you have any questions about this stuff.